Hi everyone, good evening. Welcome to my channel Belagali's class. Belagali's class. Yes, friends, we have started with quadratic equations. That will be the fourth chapter, quadratic equations. Already I have taken 3 classes with quadratic equations. In the third class, I have done, see my friends, about the quadratic equation. This is the quadratic equation form where a should not be 0, b comma c they are real numbers, numbers. We have done some varieties of the examples. First, the basic examples, check exercise 10.1. Then second method of solutions. There are 3 methods. One method, solving by the method of what? Factorization. We have done examples. Examples under what? 10.2. And just next I have done the second method. That second method is solving the quadratic equation by completing the square. That is second method, M2. M1, first method, factorization. There is one more method, that is M3. In method of squaring, we applied this man. What is it? If it is square of the first term plus 2 times a into b plus b square is nothing but what? A plus b the whole square. This is, we got it with the help of this above. A plus b the whole square is this, changing RHS to LHS. But here, this is first term, second term. In finding the second term b, you know, 2ab upon 2a, 2a cancels to get b. But what is 2ab is a middle term. Therefore, to find the second term, middle term, given middle term divided by 2 times the first term. And another, my friends, add both sides, half the coefficient of x the whole square. While applying this half the coefficient of x the whole square, we must see that coefficient of x square must be 1. If it is other than 1, divide in squaring, adding both sides. Otherwise, if you go with this method, in finding the second term, this is given middle term divided by 2 times the first term. That gives the second method. You can apply this or that method. Everything we have done in case of what? M2. In the previous video, all varieties of the examples we have done under what, my friends? Exercise 10.3. Exercise 10.3. We have done half of the examples. Next, my friends, after first method, second method, then the third and the last method is M3, method 3, M3. Formula method it is. Formula method of solving the quadratic equation ax square plus bx plus c equal to 0. This is as usual, a not equal to 0, b comma c, they are real numbers. Yes, my friends, this is the method. I write once again, the given equation is this, ax square plus bx plus c equal to 0. In this map, you have to either you have to divide by a. Divide by a means to make the coefficient of x square 1. At that time, you have to add both sides by what? Half the coefficient of x the whole square. That method. We have done many examples by that method. Another method is what? Instead of dividing, you have to multiply the given equation or each term of the given equation by what? A. Then I go with what? That second method. What is that second method? Multiply both sides of given equation by a. That becomes simple. Yes, my friends. See, given equation is this. Name this as equation 1. Multiply both sides of the equation 1 by a. Either divide or multiply. I have adopted, used what? The second method, multiplication. Each term of, or both sides, each term, a square x square, a plus abx plus A into C is plus AC equal to 0. Shift third constant term to RHS. Plus becomes minus. You have this man. What is A square? X square can be written as AX the whole square. This is given middle term. This is the constant last term. It is shifted to RHS. Yes, my friend, we want to make a perfect square now. LHS. Square of the first term, 2 times the first term. This, my friends, here. Square of the first term, 2 times the first term into second term. In finding this second term, B, what you have to do? The given middle term divide by what? 2 times the first term. 2 times the first term. See, my friend, where it is? Where it is? This is the middle term, ABX. Middle term, ABX. Divide this by 2 times the first term. 2 times the first term is AX. First term is AX. Yes, friend, simplified A and X cancels. You get this equal to what? B by 2. That B by 2 is your second term. I have written B by 2. Then square of the second term. And it is added, my friend, if you simplify this, 2 cancels ABX, which is here. Then we wanted to make a square, add it. This addition should be both sides to LHS as well as RHS. This term, B by 2 the whole square to the LHS to the RHS. Rest is simplification. A square plus 2AB plus B square. First term plus second term the whole square equal to minus AC. Simplify B square by 4. Yes, RHS. Cross minus 4AC plus B square upon 4, which is LHS. Therefore, AX plus B by 2 the whole square equal to everything. First plus B square minus 4AC upon 4. Take the square root. Square root. Plus minus square root of the numerator upon square root of the denominator. Square root of the numerator. Square root of 4 is what? 2. I have taken plus minus. Shift B by 2 to this side. Shift B by 2 to RHS. So AX equal to, what is this? It is minus B by 2. AX equal to minus B by 2 plus minus this. 2 is the LCM. Minus B plus minus square root divided by 2. Then solve for X. So X equal to, bring this A down. 2 with this A becomes what? 2A. Therefore X equal to minus B plus minus square root B square minus 4AC upon 2A. Therefore, my friends, you have 2 values of X. One value of X is with plus, another value of X is with minus. These 2 values of X gives the roots of the given quadratic equation. One is with plus sign, another is with minus sign. But it should be real, my friend. This should be real. This is real only when the expression inside the square root must be positive. Therefore, I have written here, if B square minus 4AC is either positive or equal to 0, then the given equation AX square plus BX plus C equal to 0 has 2 real and distinct roots. One root with plus, I denote by the letter alpha. Another root by minus, I denote the second root by what? Beta. So alpha is minus B plus square root divided by 2A. Beta is minus B minus square root B square minus 4AC upon 2A. These are the 2 roots, real and distinct roots under the condition. What is that condition? This expression B square minus 4AC must be either greater or equal to 0. By chance, if it is a negative, if this B square minus 4AC is a negative, then the roots of this equation are not real. Further, my friends, we introduce what? Imaginary number. With the imaginary number, we define the complex numbers. Everything will be studying the next one. PUC first year, if you come to there, 11th standard, you have what? A chapter complex numbers. In that, you are going to study in detail what about the imaginary complex numbers, everything. When square is negative, you are going to study. Yes, my friends. Highlights the given equation. You wanted to solve it by what? Method of formula. By formula method, given equation, instead of division, I have considered multiplication. Either you must go with a divide by a to make it the coefficient of x square 1. You know the rest. We have done plenty of examples in the second method of squaring there. I have adopted with what? Other method. What is other method? Instead of division, multiply both sides of equation 1 by a. We have written this. Shift to RHS. Yes, my friend. We want second term. What is this? A square. Square of the first term. 2 times first term into second term. How to get the second term? To get this second term, divide the middle term by what? 2 times the first term. Everything explained. I have written here. This is middle term. 2 times the first term. AX. AX is gone. We left with B by 2. So second term is B by 2. Square of the second term. This are both sides to LHS as well as RHS. Yes, my friend. A square plus 2ab plus b square, nothing but a plus b the whole square. First term plus second term the whole square equal to minus AC. Simplify. B square by 4 cross this. Rewrite. First b square minus 4ac upon 4. Take the square root. Square root equal to plus minus. Square root of the numerator divided by square root of the denominator. As denominator is 4, its square root is 2, my friend. Shift that side. Minus b by 2. Simplify it. 2 is LCM. Minus b plus minus square root divided by 2. Therefore, solve for x. A down. 2 with a is 2a. This is solving for x. You get 2 values of x. One value is with plus, another value is with minus. These are the 2 roots, my friends. One root is with a plus sign, another root is with a minus sign. Under the condition, this expression must be greater or equal to 0. Greater or equal to 0. I have written therefore, if this is greater or equal to 0, then roots of this given equation are real and distinct. The roots are first root, it is a symbol alpha with plus sign, beta with minus sign, there is a symbol. They are the roots. By chance, if it is negative, then roots of the given equation, they are not real. Yes, my friends. This is about the third method, M3. I give 1 minute time, copy it. copied. Yes, my friends. Third method, formula method of solving this equation. Formula method solving this equation. Yes, my friends. If this is the equation, then what is the solution? Then solution is, or formula method of solution is x equal to minus b. Otherwise, I write here down on method of solving is, this is quadratic equation, then solution is what? X equal to minus b middle term plus minus square root of square of the middle term b square minus 4 first term into last term 4ac. This is 4ac upon 2a, 2 times the first upon 2a. This is x, solve for x, solving with plus one root with minus another root. Remember my friends, this. Remember this. What is another thing? If this b square minus ac is greater or equal to 0, roots are real. If it is a negative, roots are not real. If it is negative, roots are not real. If b square minus 4ac is negative, then roots of the equation, roots are not real. That's all. Not real. Yes, my friends. Then we have to do examples based on this formula method. It is called as solving by formula method. This is the formula. This is the formula. Yes, friends. Examples. Once again, that comes under exercise 10.3, my friends. This, once again, exercise 10.3. This 10.3. They give like this, my friends. Find the roots of the given equation. Find the roots of the equation. Means quadratic equation that is understood by formula method, by applying formula method. Yes, my friend. First example. First example. 3x square minus 5x plus 2 equal to 0. You have to compare this with your standard comparing this with that is standard equation ax square plus bx plus c equal to 0. We have, tell friend, a 3, b is minus 5, c is 2. Then what is the formula? Formula is x equal to minus b plus minus square root b square minus 4ac upon 2a. First we have to find this man. If b square minus 4ac is positive or 0, real, negative, imaginary. Find it first. So b square minus 4ac b square minus 5 the whole square minus 4ac a is 3, b is 2. What is this? It is 25 minus 24, 12 into 2, 1. 1 is a positive number. 1 is a positive number. This is positive means what? Roots are real. Therefore, b square minus 4ac equal to 1, which is positive, implies roots are real. Real and distinct, different roots. Different, both are different. And they are, roots are, and they are, see, one root, first root, what is it? Alpha equal to minus b plus square root upon 2a. What is it? It is minus b, minus of minus plus 5, minus of minus plus 5, plus, what is square root of this? What is b square minus 4ac is 1. It is square root of 1. Denominator is 2 into a is 3. What is this? It is 5 plus 1 upon 6. 6 upon 6 means 1, alpha is 1. And beta is second root. Beta is, what is it? Minus b minus square root b square minus 4ac upon 2a. Yes, minus b, minus of minus. Minus 1 down is 2a, 2 into 3, which is 4 by 6. 4 by 6 means 2 by 3. Therefore, the required roots are, first root is 1, second root is 2 by 3. First root is 1, second root is 2 by 3. Yes, my friends. This is the method of finding the roots of the equation by making use of what? Formula method. By making use of formula method. Yes, my friend. Another example. Another example. Same statement. Same statement. Second example is 2x square minus 2 into root 2x plus 1 equal to 0. Comparing with ax square plus bx plus c What is A? Coefficient of x square. What is B? Coefficient of x. What is C? Constant. So my friend, A is 2, B is minus 2 root 2. You have to write along with a sign. C constant is 1. First you have to find B square minus 4AC. B square minus 2 root 2 the whole square minus 4 AC, A 2, C is 1. Simplify it. 2 square, 4 into 2 is 8. Minus 8. What is 8 minus 8 is 0. Therefore, my friend, B square minus 4AC equal to 0. B square minus 4AC equal to 0 implies roots are real and distinct. Roots are real and distinct, not distinct in half. In this case, roots are real and equal. How do you write roots are real? And they are first root, square root. What is this, my friend? 0. Roots are real and they are 1. Alpha equal to minus this, my friend, it is B square minus 4AC. What is this? Minus. What is your B? Minus 2 root 2. B is minus 2 root 2. This is minus 2 root 2 plus 0. Denominator is 2A. What is the value of A? A is 2. A is 2. Simplify it. This is minus of minus plus 2 root 2 upon 2 into 2. My friend, 1 2 cancels. Root 2 upon 2 means root 2 cancels with here. Root 2 cancels. Therefore, first root is root 2. You will be getting the same here also. So, we can, same minus. What is it? This is minus plus 2 2 minus 0 upon 2 into 2, which is 2 root 2 upon 2 into 2. Same, once again, cancellation, you get 1 by root 2. Therefore, the required roots are 1 by root 2, 1 by root 2. 1 by root 2, 1 by root 2. 1 by. This is the second example. I do, my friends, one more. Yes, one more. Yes, friend. Solve by formula method, or find the roots of the equation by formula method. Yes. It is 2x square plus x minus 4 equal to 0. Yes, friend. A is 2, B is 1, C is minus 4. So, find first B square minus 4AC, B square 1 square minus 4 into A is 2, C is minus 4. What is this? 1 minus with minus is plus 8. 8 into 4 is 32, which is 33 means positive. Therefore, roots are real and different. Positive means real and different. Distinct. Yes. What about the roots? Now, what is the square root of this? Is root 33. Therefore, roots are real and distinct, and they are First, alpha. What is alpha? Minus b plus square root b square minus 4ac upon 2a. Upon 2a. What is this, my friend? Minus b minus 1 plus square root 33 upon 2a. 2 into a is 2. 2 into 2 is 4, my friend. This is one root. What about the other root? Minus. So, beta is second root. It is minus 1 minus root 33 upon 4. Plus minus, my friend. Plus is first root. Minus is second root, which is beta. Yes, friend. See, the next example is 2x square. This is plus x, so plus 4 equal to 0. Instead of minus, it is plus. Same. A is 2. B is 1. What is C? Plus 4. B square minus 4ac. Tell friend, b square minus 4ac. A. C is 4. What is this? 1 minus 32. 1 minus 32. 8 into 4 is 32. What is this, my friend? Minus 31 negative. Therefore, b square minus 4ac is a negative. B square minus 4ac is negative. When b square minus 4ac is negative, roots are not real. Implies roots are not real. Means real root doesn't exist. Real roots doesn't exist. Roots are not real. You mean the given equation doesn't have real roots, or real roots of this equation does not exist. You can write anyway. Roots are not real. Yes. Roots of the given equation are not real. Does not exist. Real roots does not exist. Yes, my friend. Last one more example is. Right. This is 4x square plus 4 into root 3 into x plus 3 equal to 0. This is also by formula method. Compare. A is 4. B is 4 into root 3. C is 3. First you have to find what? B square minus 4ac. B square 4 into root 3 the whole square minus 4a 4. C is 3. What is this? 16 into 3 square minus 16 into 3. 4 into 4 is 16 into 3. What is this, my friend? It is 48. Minus 48 means 0. Therefore, b square minus 4ac is 0. Implies roots are real. Roots are real. And they are. Roots are real and They are. They are, yes. Alpha equal to what? Minus b plus square root b square minus 4ac upon 2a. First root. Tell. Minus b. What is b? B is 4 root 3. 4 root 3 plus 0 upon 2 into a is 2, my friend. 2 into, no, a is 4. A is 4. A is 4 equal to minus 4 root 3 upon 2 into 4. 4 cancelled. You are left with minus root 3 by 2. Similarly, what is beta? It is minus b minus square root upon 2a, which is minus b by 2a. That is minus 4 into root 3 upon 2 into 4. Again cancels. You have minus root 3 by 2. Therefore, the required roots are minus root 3 by 2, minus root 3 by 2. This is the solution of given quadratic equation by formula method. Yes, my friend. This is the third method. These are the three methods, my friend. First is factorization. Second is method of completing the square. Third is formula method. These are some examples. Then I do some typical examples on formula method, my friends. Some typical examples on formula method. Yes. These examples are slightly lengthy. First example is find by the formula method, solve by the formula method. This example is, yes, it is x minus 1 by x equal to 3, where x is not equal to 0. You know the danger line. Simplify it. Multiply both sides by x. Multiply both sides by x. My friend, x into x minus x cancels equal to 3x, 3 into x. Bring this side, x square minus 3x minus 1 equal to 0. Comparing this with ax square plus bx plus c equal to 0. What is the value of a? 1. What is b? Minus 3. What is c? Minus 1. First you have to find that expression b square minus 4ac that decides the nature of the roots. B square minus 3 the whole square minus 4 into a into c is minus 1. Friend, 9 minus with minus is plus 4 into 1 equal to 13. 13. Therefore, the roots are, I write direct here, my friend, no alpha, beta. Therefore, the roots are x equal to minus b plus minus this upon 2. What is it? Minus b minus 3 plus minus square root. What is b square minus 4ac? B square minus 4ac is 13, which is positive, so the roots are real. Real. Yes. It is root 13 upon 2a. The value of a is 1. A is 1. Simplify. 3 plus minus root 13 upon So, two different roots. When you can conclude here itself, not necessary this. One is with plus sign, another is with minus sign. The same above, that plus minus you are writing what? Separate. One with plus, another with minus. Otherwise you can write here itself. These are the two roots. Sometimes they give like this, not in the standard form. You have to bring it to the standard, then compare. Then one more is there in your textbook, my friends. It is also slightly lengthy. Simplification like this is lengthy. Next is 1 upon x plus 4 minus 1 upon x minus 7 equal to 11 upon 30. It is also there in your textbook. You have to simplify it, that's all. So it is simplified. First cross multiplication. X minus 7 minus 1 into x plus 4. Denominator LCM is what? It is x plus 4 into x minus 7 equal to 11 by 30. Simplified. X minus 7 minus x minus 4. It is what? X into x is x square minus 7x plus 4x minus 28 equal to 11 upon 30. What cancels, my friend? Plus x cancels with minus x. It is minus 7 into minus 4 is minus 11. Bring this 30 this side, 30 equal to. This side is 11 into this denominator x square minus 7x plus 4x. Minus 7x plus 4x is minus 3x. Minus 28. What is done? It is minus 11 upon x square minus 3x minus 28 equal to 11 by 30. Cross multiplication. Minus 11 into 30 equal to 11 into this denominator x square minus 3x minus 28. Anyway, this 11 is common from both sides. Cancel it. Write the rest. What is it? It is minus 30 equal to this. X square minus 3x minus 28. Bring this minus 30 this side. It is x square minus 3x minus 28 plus 30 equal to 0. C. X square minus 3x plus 2 equal to 0. Once again, comparing with what? Standard form. You get value of A is 1. B is minus 3. C is 2. Yes, my friend. This is all the steps to bring what? The given equation to the quadratic form. Once it is in the quadratic form, compare with what? Ax square plus bx plus c equal to 0. A is 1, b is minus 3 and c is plus 2. Then you have to find what? B square minus 4ac. B square minus 4ac 1 into 2. What is this? My friend, it is 9 minus 8, which is 1. 1 means what? Positive. Therefore, b square minus 4ac equal to 1, which is positive, implies roots are real and different. Roots are real and distinct or different. And what are the roots? X equal to minus b plus minus square root b square minus 4ac upon 2a. Substitute the values equal to minus b, what is b? Minus 3, minus with minus is plus 3, plus minus b square minus 4ac is 1, square root of 1 is 1, down is 2a, a is 1. So, what is this, my friend? It is 3 plus minus 1 upon 2. Yes, therefore, roots are first, which plus 3 plus 1 by 2, which is 4 by 2 is 2. This is 1. Then second is, what is second? With minus sign, 3 minus 1 upon 2, which is 2 by 2, that is 1. Therefore, the roots are 2 comma 1. Roots are 2 comma 1. Yes, my friends, these are the two examples. Two examples, slight different. Yes, my friends. Yes. Yes. Then comes nature of the roots. I hope understood everything. Understood. Yes. Next, my friends, nature of roots. Yes, friend. I hope copied. Nature of roots of quadratic equation. Ax square plus bx plus c equal to 0. Yes, friends, or you can write simply nature of roots. It is understood. It is roots of this equation only. Yes. Yes, friend. Here, the equation is, quadratic equation is standard form ax square plus bx plus c equal to 0. Where a is not equal to 0, that's that they are real numbers. Then you name this as equation 1. This is equation 1. Roots of equation 1 are roots. Equation 1 are given by x equal to minus b plus minus square root b square minus 4ac upon 2a. Yes, my friend. This expression plays a very important role. The expression b square minus 4ac is called discriminant of the equation. Is called discriminant. Discriminant. Discriminant of the equation and is denoted. Discriminant of the equation and is denoted by, in some books it is given as capital D, in some books it is given as delta. This is capital delta. Capital delta, this is like a letter, it is capital delta, this is capital D. Therefore, I take my friend D is what? B square minus 4ac. What is it? This is known as discriminant. It plays a very important role. Discriminant of the equation. Discriminant of the equation. Then, my friends, this roots of the equation depends upon this discriminant. The nature of the roots depends on D, discriminant. We will see how it depends. See. Yes. Yes. The value of D determines the value of D determines the nature of the roots. Nature of the roots. That is understood. I am not going to write every time roots of the equation. And that is this. So, my friend, this is the standard form of the equation. We derived by formula method. The value of x is minus b plus minus root b square minus 4ac upon 2a. There are two roots, my friend. One is with plus, another is with minus. First root, normally we denote by what? Alpha. Second root, we denote by what? Beta. These are the standard roots, symbols to denote the roots of this quadratic equation. Yes. This expression, b square minus 4ac, its name is discriminant of the quadratic equation and is denoted by either capital D or capital delta. I take this D man. D equal to b square minus 4ac. The value of D determines the nature of the roots. This value of D. Then D comes, man. What are the values? What are the values? D. If D comes, what are the values? D may be positive first. D may be equal to 0 second. D may be less than 0, which will be third. Yes, my friend. Now we will discuss one by one. What is first? Let D is greater than 0. Right, my friend. First case. Case 1. Let D equal to b square minus 4ac is positive. Then tell my friend, when this is positive, what about D? D is real. And we get two real and distinct roots. Distinct means different roots. Yes, my friends. Already we have seen with this case, if D equal to b square minus 4ac is positive, then root D is real. And we get two real and distinct roots. And roots are roots are 1. Or I write here roots are x equal to minus b plus minus square root d divided by 2a. Then what are the roots? One is with plus sign, another is with minus sign. This is first. Second case, tell. If this is equal to 0, let d equal to b square minus 4ac equal to 0. Then d is 0. Then roots are real means actually you get what? Rational roots. Rational and equal. Roots are real means in particular rational and equal. They are x equal to, tell, it is minus b plus minus 0 upon 2a. Therefore, two equal roots, b upon 2a, they are rational. B upon 2a, first root, even second root is also same. This is second case. Third case, let d equal to b square minus 4ac is negative. Tell. Is negative. Then roots are not real. Actually, we are not having in detail of it. Simply we write roots are not real because when a square is negative, mathematicians introduced a new number called as imaginary number denoted by I. Imaginary number denoted by I. With the help of this, mathematicians introduced another type of number. That number is known as complex number, that you are going to study in the higher class. Yes, my friends. These are three cases. And one more case is d equal to a perfect square. If d is a perfect square, what about square root of d is a rational number? If you wanted, there is a special case, that is fourth one. If d equal to b square minus 4ac is a perfect square. Then square root of d is rational. Why, my friend? D is a square, perfect square. Square root square is what? D itself, which is rational. Therefore, roots are rational and different and distinct. Roots are rational and distinct. These are four different cases, my friends. So, this is the equation, solution, expression, discriminant. That value of the discriminant decides the nature of the root, roots. What are the values? That d may be positive, you have real and distinct. D may be 0. 0 means what? Roots are real and equal. This is second. What is this? Negative. Roots are not real. What is the fourth one? D equal to b square minus 4ac is a perfect square. When d is a perfect square, root d is what? Rational. Then what are the nature of the roots? Roots are rational and distinct. Rational and distinct. Yes, my friends. These are the nature of roots of the equation. Nature of roots of the equation. Yes, my friends. I do one sample example. Sample example. Yes. These examples comes under exercise 10.4. We have completed 10.3. We have completed examples on exercise 10.3 under M3 and M2. Method of square and formula method. Formula method. We have done examples on this 10.3 here. Then on nature of the roots. Nature of the roots. Examples will be under 10.4. 10.4. Yes, friends. Exercise 10.4. 10.4. Find the nature of. Find the nature of roots of the following quadratic equations. Roots of the following quadratic equations. If real root exists, continuation. If real roots exist, find them. Find them. My friends must remember this D. D positive, D 0, D negative, D is a perfect square. Remember. First example. It is 2x square minus 3x plus 5 equal to 0. Yes, my friends, first example I write in detail, comparing this with standard equation. What is the standard equation? Ax square plus bx plus c equal to 0. We have the values, my friends. We have a2, b is minus 3, this, and c is 5. You have to find the value of d. D is what? B square minus 4ac. B square minus 3 the whole square minus 4 into a into c is 5. What is this? 9 minus 5 into 2 is 10, 40. What is it? Minus 31. Minus 31 means negative. Therefore, D negative. D negative implies roots are not real. Roots are not real. Not real. Not real. Yes, my friend. Second example. Second example is. Yes, my friends. The remaining examples. A few more examples I do. Okay, in the next class, my friends. Next class. Yes, my friends. I hope everything will be clear. Everything will be clear. Yes. Today, this much is enough for my friends. Yes. Note, we went through the third method, that is formula method, in this class. After finishing the examples on formula method, we have discussed about what? Nature of roots of the quadratic equation. This is the nature. I have done one sample examples, my friends. I'll do a few more examples in the next class or video. Till then, enjoy. Yes, my friends. Bye. Namaste, Namaskara, Namashinyam. Yes, my friends.